Algebraic solutions of linear inequalities in one variable and their graphical representation. Let us consider the inequality 30x is less than 200, which was previously discussed as well. Note that here x denotes the number of packets of rice. Obviously, x cannot be a negative integer or a fraction. Left hand side of this inequality is 30x and right hand side is 200. Therefore, we have for x equal to 0, LHS is equal to 30 into 0. Therefore, 0 is less than equal to 200, which is true. For x equal to 1, LHS is equal to 30 into 1 and 30 is less than 200, which is true. For x equal to 2, LHS is equal to 30 into 2, which is equal to 60, and 60 is less than 200, which is true. Similarly, for x equals to 3, 90 is less than 200, which is also true. For x equal to 4, 120 is less than 200, which is true. For x equal to 5, 150 is less than 200, which is true. And for x equal to 6, 180 is less than 200, which is also true. But for x equal to 7, we get 210 is less than 200, which is false. In this situation, we find that the values of x, which makes the above inequality a true statement, are 0, 1, 2, 3, 4, 5, and 6. These values of x, which make above inequality a true statement, are called solutions of inequality, and the set 0, 1, 2, 3, 4, 5, 6 is called its solution set. Thus, any solution of an inequality in one variable is a value of the variable, which makes it a true statement. We have found the solutions of the above inequality by trial and error method, which is not very efficient. Obviously, this method is time consuming and sometimes not feasible. We must have some better or systematic techniques for solving inequalities. Before that, we should go through some more properties of numerical inequalities and follow them as rules while solving the inequalities. You will recall that while solving linear equations, we followed the following rules. Rule 1. Equal numbers may be added to or subtracted from both sides of an equation. Rule 2. Both sides of an equation may be multiplied or divided by the same non-zero number. In the case of solving inequalities, we again follow the same rules except with a difference that in Rule 2, the sign of inequality is reversed. That is, less than becomes greater than, less than equal to becomes greater than equal to, and so on. Whenever we multiply or divide both sides of an inequality by a negative number, it is evident from the facts that 3 is greater than 2, while minus 3 is less than minus 2. Minus 8 is less than minus 7, while minus 8 into minus 2 is greater than minus 7 into minus 2. That is, 16 is greater than 14. Thus, we state the following rules for solving an inequality. Rule 1. Equal numbers may be added to or subtracted from both sides of an inequality without affecting the sign of inequality. Rule 2. Both sides of an inequality can be multiplied or divided by the same positive number. But when both sides are multiplied or divided by a negative number, then the sign of inequality is reversed. Now, let us consider some examples. Example: solve 30x less than 200 when x is a natural number and x is an integer. Let us see the solution. We are given 30x is less than 200 or 30x by 30 is less than 200 by 30. That is, x is less than 20 by 3. In case 1, when x is a natural number, the following values of x make the statement true: 1, 2, 3, 4, 5, 6. The solution set of the inequality comprises of these values. When x is an integer, the solutions of the given inequality are -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. Note that we have put up 3 dots before -3. This represents that all numbers less than -3 will also be in this series. But since integers are infinite, we cannot write them all. Thus, the solution set of the inequality is, since minus infinity cannot be written, we are writing it as ... comma -3, comma -2, comma -1, comma 0, comma 1, comma 2, comma 3, comma 4, comma 5, comma 6. Let us take another example. Solve 5x minus 3 less than 3x plus 1 when x is an integer and x is a real number. Let us see the solution. We have 5x minus 3 less than 3x plus 1. Now we add plus 3 to both the sides. So we get 5x minus 3 plus 3 less than 3x plus 1 plus 3, or 5x is less than 3x plus 4. Now we subtract minus 3x from both the sides. So we get 5x minus 3x less than 3x plus 4 minus 3x, or 2x less than 4, or x less than 2. Now in case 1, when x is an integer, the solutions of the given inequality are -4, -3, -2, -1, 0, 1. Again in this case, all the integers less than -4 will also comprise the solution. In case 2, when x is a real number, the solutions of the inequality are given by x less than 2. That is, all the real numbers x which are less than 2. Therefore, the solution set of the inequality is x belonging to the set of minus infinity to -2. We have considered solutions of inequalities in the set of natural numbers, set of integers, and in the set of real numbers. Henceforth, unless stated otherwise, we shall solve the inequalities in this chapter in the set of real numbers. Let us take another example. Solve 7x plus 3 less than 5x plus 9. Show the graph of the solutions on a number line. Let us see the solution. We have 7x plus 3 less than 5x plus 9, or 2x is less than 6, or x is less than 3. Note the graphical representation of the solutions. Let us take another example. Solve 3x minus 4 by 2 greater than equal to x plus 1 by 4 minus 1. Show the graph of the solutions on number line. Let us see the solution. We have 3x minus 4 by 2 greater than equal to x plus 1 by 4 minus 1, or 3x minus 4 by 2 greater than equal to x minus 3 by 4, or 2 times 3x minus 4 is greater than or equal to x minus 3, or 6x minus 8 is greater than or equal to x minus 3, or 5x is greater than or equal to 5, or x is greater than or equal to 1. The graphical representation of solutions is shown in the number line. Let us take another example. the marks obtained by a student of class 11th in first and second terminal examinations are 62 and 48 respectively. Find the minimum marks he should get in the annual examination to have an average of at least 60 marks. Let us see the solution. Let x be the marks obtained by student in the annual examination. Then 62 plus 48 plus x by 3 is greater than or equal to 60, or 110 plus x is greater than or equal to 180, or x is greater than or equal to 70. Thus, the student must obtain a minimum of 70 marks to get an average of at least 60 marks. Let us take another example. Find all pairs of consecutive odd natural numbers, both of which are larger than 10, such that their sum is less than 40. Let us see the solution. Let x be the smaller of the two consecutive odd natural numbers so that the other one is x plus 2. Then we should have x greater than 10 and x plus 2 less than 40. Let's call these inequations number 1 and 2. Solving number 2, we get 2x plus 2 is less than 40. That is, x is less than 19. Let's call this inequation number 3. From inequations 1 and 3, we get x is greater than 10 and less than 19. Since x is an odd number, x can take the values 11, 13, 15 and 17. So, the required possible pairs will be 11, 13, 13, 15, 15, 17 and 17, 19. Let us take another example. Solve for x the inequations 4x plus 3 is greater than or equal to 2x plus 17 and 3x minus 5 is less than minus 2. Let us see the solution. Here 4x plus 3 is greater than or equal to 2x plus 17, which implies 2x is greater than or equal to 14, or x is greater than or equal to 7. Also, 3x minus 5 is less than or equal to minus 2, which implies 3x is less than 3 or x is less than 1. Here, x is less than 1 and at the same time greater than or equal to 7, which is not possible. Hence,